strain. Can someone tell me what the equation is for that?
L
Yeah.
naught.
Just P over the cross sectional area.
Alright,
No,
strain.
sorry.
Extension divided by
Yeah, L minus L naught over L naught.
There you go. So delta L over L naught. So divided by 31.6. What you can do is double click this and it creates all your data for you.
Oh.
I just dragged it through
Yeah.
all the
Yeah, it
results.
takes. Now for stress, someone tell me the equation for stress.
Was it the load?
Yeah, it's just load over a cross sectional area.
Okay.
Would you divide the load by 1,000 too, or you multiply it by 1,000 here to get it in megapascals?
Exactly. You have to multiply it by 1,000 to get it in megapascals. Because you're in kilonewtons, you want it in newtons per millimeter. Right, so kilonewtons times 1,000 newtons over kilonewton, you get into newtons. So, let me double click that. There we go.
Wow.
Now, some reason, if you have letters there, it doesn't let you graph it out, but you click D, hold down Shift, click E, insert, scatter, do the dots first, and you get that. Now you see that you have a data point at the bottom, so you want to delete that last data point. You can tell that your stress values are all consistent up until 335 to 194. Clearly that's too much of a drop, so you just delete this last row of data. Go back to the top. Data point's gone. So now you don't want to have 4 different thick lines like that, so you can select the data, sorry, not select data, right click, change series type, change it to this one right here, scatter with straight lines. It's better than the curved lines because each one has to estimate a curve for points versus just connecting the dots. Now you've got a really thin line. So the first value is Young's modulus. So what you want to do is you want to grab the linear data. So it looks linear, I mean, right there, but I'll start at 50 and go up maybe to 250. So here's your stress, right? Your strain, your stress. I'm going to go down to stress of 50. So right there. And you want to go down all the way to 250. So right there. So hold down Shift right there. Click. All that data is now highlighted, so I can insert another scatter plot. And you get a straight line just of the 50 to 250. There's another way of doing it too, where you put limits on the y-axis, but you can do it this way. Right click the curve, not here, but the actual curve, add a trend line. And now it's not linear. So you want to display the equation on the chart and the r-squared value. Now this gives you a y equals mx plus b equation. What is the Young's modulus from this?
dm
Yep. So what would that be from here?
3,600.
Wait,
Wait,
yeah.
30,644.
There you go. So now we have 30,644. Okay, now yield strength. You want to create a line that's offset from this Young's modulus by 0.2%. So it kind of goes along to the right of it and intersects the curve right there. So what we're going to do is use the same strain values, but create a new line using those strain values. Because y equals mx plus b, what does the y refer to?
The Y is
Stress.
the stress.
And the x is the strain. So the yield strength, we'll call this yield strength line, y equals, because basically yield strength line stress values equals m, which is 30,644, times parentheses x, which is strain, so you click that, minus 0.002. Because of 0.002, if you do subtract, it's basically taking this line and shifting it to the right.
When you
Okay.
add from below
So if you add it, it moves it to the left.
to- Oh.
So the reason being is when you subtract it, if you do it out, if you compared it to this, you'd see it goes to the left instead.
Why are we shifting it 2%?
So if you read in the book, it kind of describes that once you get up to a yield strength and you let off the stress completely, it goes back to a strain that's like 0.2% of the original strain. So it's slightly extended, and then they just said, oh, all we need to do is connect the straight line. Same slopes.
Why isn't it 0.02?
Oh, 0.2%. You
Oh,
divide it.
0.2%.
Yeah, 0.2%. And then plus B, which is minus 251.01. Now double click that. And it's negative because at zero strain, right there, zero strain along the x-axis, it should be a line that starts there and zooms up. So you get a negative first. Now at that intersection point, that's your yield strength, right? So at that point, both lines, both the one you just created and this one, should have the same both strain value and stress value. Because whenever 2 points intersect, they have the same x point and the same y point. So if they're sharing these x points, can anyone think of how you could find the intersection if you have this data and that data?
Find the difference where it's small.
Yeah, exactly. Find the stress difference because they share the same strain value. So wherever the stress values are the same, strain values are the same, stress values are the same, you have the intersecting point. So what you can do is subtract one from the other. That minus that. Double click it. Go down, find where it's 0, and right there is closest to 0. So you go to your original stress value, and that's your yield strength. So
Because the yield strength is where?
these lines intersect, or these points are basically the same. So, and you can zoom in at 320 anyways and see that yield strength is right around there. So, also if you wanted to really add data, you could right click, select data, add. Your x values could be strain from 0 to, let's see, sorry, 0 to, here, your y values. 365. I think that should do it. There you go. So they intersect right there. So, anyways, now you've got your yield strength. If you want to copy a cell and paste it, what you do is you right click. Actually, yeah, so it's about 322 megapascals. UTS is just the maximum of all that data, all the original stress data. It's the ultimate tensile strength, so you highlight all the data, and then it gives you a value. It should be, the maximum. Toughness, area under the curve. So what's the area under the curve for the very first point?
0.
0, because you haven't gone anywhere yet, so there's no area. The second point is, does anyone remember the equation?
FB plus FY times
That
B minus
factors or something.
So, this, yeah, strain 2 minus strain 1 times,
Load
just
or
2 minus
stress.
stress 1.
2 seconds.
I think it's plus, right?
yeah, because you want to average these
And
two
then divide
out.
by 2.
There you go. And it gives you the area, but you could prove it to yourself too, but the area of that trapezoid. Get that, double click it, go to the very bottom. Sometimes at the very bottom there's like a negative value. Always delete that value. So then what you do is you use the sum function and sum from here. Oh, sorry. From here to here. And there you go. 108 megajoules per meter cubed. Ductility, does anyone remember the equation for that?
It's like failure or something.
It's the strain at failure, so that value right there, minus the stress at failure, that value.
Divide by
Yeah, 30,644.
What about what?
Young's
Young's
modulus.
modulus.
And all this is on the PowerPoint too, as well as in the book. And there you go. You got a ductility right there. So these are your 5 values. How long was that?
10 minutes.
Yeah, so